Okay, so we're back to writing equations for quadratics. Now, in the last video, we watched if there was a vertex and the point, we used vertex form to find the equation. And this time, we're going to be given the x-intercepts or intercept and a point on the graph. And so, in this case, we want to use the standard form, which is y equals ax squared plus bx plus c to write our equations. Now, I want to back up and just talk just a little bit about if I'm given or how I find the x-intercepts, okay? If you'll remember, if we had an equation, let's give you something easy that you could do. So if I had the equation here, then I took my equation and I factored it, okay? And then I set each factor equal to 0, and in which case this was a -3 and this was 1. Now in the problem above, what I'm given is 2, 0. And what I want you to notice is that if this is a -3, then when I put it into my equation, it actually becomes a +3. So you could do this problem several different ways. Now the other thing to mention is that just because this is what I factored, it doesn't mean that I could not have taken out a common factor of 2 to start off with, which would be my a value. So that's also going to come into play. So let's just back up then to the problem that we have here. And if I was doing this problem, and I'll go ahead and put in the steps, then I know that x equals 2 and x equals 4, which means that this is x minus 2 equals 0 and x minus 4 equals 0, which means that if I go back to my equation, it would be this. And so then if I factor, or I'm sorry, if I FOIL, then I am going to get my equation that looks like this, okay? But again, I just stated that because I have this to factor does not mean that at some point I could not have taken out a common factor in the problem. And we also know that since we're looking for our equation, we know that this is y, okay? So this is what I have. Now I'm going to go back to what else I was told. So by using this piece, I now have this piece of my equation. But I'm also given that I have the 0.13. So I can use that 0.13 to find my a value just like I did above. So here we have a times, and this would be my x and my y, so it would be 1 squared minus 6 times 1 plus 8 equals y, which is 3. I'm just going to do some simplifying here. So that would be 1 minus 6 plus 8, which in this case would be 3, right? So I have 3a equals 3. So a is 1, which simply means that I did not take out a common factor, and therefore my equation would be the y equals x squared minus 6x plus 8. Okay? But you do have to check to see if you took out that common factor. Okay? Now, next question is, do you really need to show all of this work? Well, no, not necessarily. If you understand the concept and can skip to that, and so this one would be x minus 3, x minus 5, and we know that this does equal y, so I can put y equals, okay? I need to go ahead and FOIL, so x squared minus 3x minus 5x plus 15, so y equals x squared minus 8x plus 15. Okay, so again, now I need to check my a value. Did I take out a common factor before I begin? So I'm going to go through and I'm going to check for an a value. Whoops, I'm going to take that off here, okay? So I'm going to check for an a value. Was there one? Okay, and now I'm going to put in my x and my y that was given. So y is 3, x is 2, okay, and so that's 4 minus 16 plus 15, which is a 3. So no, a was just 1. I need to find some equations that don't work out this way. And so y equals x squared minus 8x plus 15 is my final answer. Okay, but don't forget you do need to check for the a value. Okay, so again, that is how to find the equation given the x-intercepts and a point on the graph.